Very good morning everyone. Today we will see the design of two-way slab. Myself Dr. J. Saharuban, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. Before starting the design, what is meant by two-way slab? Two-way slab is a slab supported by beams on all four the sides. The loads are carried by the support along with both directions. It is known as two-way slab. That is Ly by Lx. That is ratio of longer span by shorter span is less than or equal to 2 is called two-way slab. Let us see the design problem. Design a RC slab for a room measuring 6.5 by 5 meter. The slab is cast monolithically over the beams with the corner held down. The width of the supporting beam is 230 mm. The slab carries superimposed load of 4.5 kN per meter square. Use M20 concrete and Fe 500 steel. First of all, Ly by Lx is less than 2. So, if the value of Ly by Lx is less than 2, this is called a two-way slab. So, we have to design the section slab as a two-way slab. Let us find out the depth of the slab and the effective span of the slab. So, assume the depth of the slab L by 30. So, D is equal to L, already we know this is shorter span 5000 divided by 30, we will get a value of 166 mm. So, we have to choose a 160 mm depth of the slab or thickness of slab. So, overall depth we have to provide it as 180 mm. Then we have to find out the effective span of the slab. So, the effective span is list of following. First one is Ly, in the direction of Ly, we have to take it as 6.5 plus center to center support divided by 2 plus center to center divided by 2. That will be equal to 6.73. Then Lx 5 plus 0.23. So, support 5 plus 0.23 divided by 2 plus 0.23 divided by 2. That will be equal to 5.23. Like we have to find out the Ly, clear span plus effective depth, that is 160 mm. So, 6.66. Then Lx is equal to clear span is 5 meter plus 0.16 is the effective depth, that will be equal to 5.16. So, least value you have to take it as a effective span of the slab. So, Ly least we have to take it as a 6.66 and Lx is equal to 5.16. So, we have to take the value Lx in the direction 5.16 meter, Ly direction, that effective span is equal to 6.66 meter. Next we have to find out the design bending moment as well as the check for depth. So, first we have to find the alpha value, that is Ly by Lx, that is equal to 1.3. The moment along the x direction mx is equal to alpha x into wu into Lx square, like my is equal to alpha y into wu into Lx square. So, Ly by Lx 1.3. From the table number 27, page number of 91 of IS 456 2000, just we have to find out the value of alpha x and alpha y. So, alpha x is equal to 0.079 and alpha y is equal to 0.056. Then positive bending moment at the mid span mx, that is shorter span mx is equal to, substitute the value here 0.079 into 13.5 into 5.16 square, that will be equal to 28.40 kilonewton meter. Like positive bending moment at mid span of longer span, that will be equal to my is equal to alpha y into that is alpha y already we find out 0.056 into 13.5 into 5.16 square. So, that will be equal to 20.13 kilonewton meter. Okay, next check for depth for a given bending moment. So let we know m is equal to 0.138 fck into bd square. From that we have to determine the d value. So d is equal to 103 mm. So already we provided 160 mm. In this moment we are getting a value of 103. So d is less than d provided. Hence this depth is enough to carry that bending moment. So we have to provide d is equal to 160 mm. Next we have to design for reinforcement in the longer direction as well as the shorter direction. So area of reinforcement, already we know the formula for AST, that is m is equal to 0.87 Fi AST into d, 1 minus AST Fi divided by FCKB into d. So along the direction of shorter direction, mx is equal to, we have to find out using this relation. So moment along x direction 28.40 into 10 power 6. Substitute all the value and finally we'll get a value of AST is equal to 438 mm square. So provide 10 mm diameter rod at 175 mm center to center. Percentage of steel reinforcement is 0.27%. Next we have to determine the steel along shorter direction, that is my. Since long span bars are placed above the shorter span, so d we have to take it as 160 minus 10. Minus 10 is the reinforcement of main reinforcement. So that is 150 mm. So once again we have to find out the AST by using this 150 d as a 150. Substitute the value for m is equal to 0.87 Fi AST into d, 1 minus AST Fi divided by BD FCK. And finally we will solve this equation, we will get a value of AST 327 mm square. So 10 mm diameter rod were used. Using 10 mm, find out the spacing first. Spacing is equal to small AST divided by capital S, that is pi d square by 4 divided by 327 into 100. So that will be is equal to 240 mm. So provide 10 mm at 240 mm center to center. So this is a spacing. So maximum spacing up to 300 mm we have to provide. We are getting 240 mm. So we have to provide a 240 mm center to center spacing with a 10 mm diameter bars. Next we will find the shear check. Design shear VU is equal to WL by 2. So first we have to find out the value of WL by 2, that is 34.83. W already we know 13.5 into L 5.16. So tau V is equal to VU by B into D. So 34.83 into 10 power 3 divided by B into D. You will get a value of 0.217 Newton per mm square. Tau C max, we have to take the table 20, that value is 28 Newton per mm square. Then tau C value we have to determine by percentage of steel, already we have find out by 0.37. So from the percentage, table number 19 of IS 456 2000, we have to find out the value tau C, that is shear resisted by the concrete tau C is equal to 0.42. So tau C is greater than tau V. So this is safe. Finally we have to find out the deflection check. So L by D allowable is equal to L by D basic into modification factor. So modification factor is 1.5, percentage of steel reinforcement is 0.27, and then using that graph we have to find out the value of L by D allowable, that is 26 already basic value into 1.5. 1.5 is a modification factor, so we will get a value of 39. So actual value 5.16 divided by D, that is 0.16, that is 160 mm, so 32. So actual is less than allowable since the deflection check also okay. So this is a design related to two-way slab. Thank you so much.